This video is going to walk you through our area of parallelograms packet. So if you go ahead and take a look at the vocabulary startup, this is really getting us into our first official lesson of geometry. So it's going to reintroduce some vocabulary terms that you may know and you may not know or may not remember. So go ahead and take a look at the vocabulary startup and take a look at those three vocabulary words. And I'd like you to read them carefully and just make sure that you have an understanding or you're remembering what each of those means. And then we're going to fill out the Venn diagram or the circles below with each of the words that kind of show what is each type. So if you go ahead and take a look, I did fill in the Venn diagram, and the biggest circle is going to be your overarching definition of a polygon. And a polygon encompasses all kinds of different shapes, such as parallelograms, triangles, trapezoids, rectangles, squares, any figure that is a closed figure and is formed by three or more straight lines. A parallelogram gets a little bit more specific, and it is a quadrilateral, so that means it has four sides where opposite sides are parallel and opposite sides are the same length, or the word congruent. So if you see the word congruent, that means that the sides would be the same length. And then you get to a little bit more of a specific shape, which is a rhombus. And a lot of you think of rhombuses as kites or diamonds. A rhombus is a parallelogram with four equal sides. So I always say it looks like a square, but it has slanted sides. So that's why if we look at our actual Venn diagram, we can see that we have a bigger circle and then a medium circle and then a smaller circle, all using those vocabulary terms. Go ahead and take a look at the real world link and read over this. It says, how many sets of parallel lines are shown in the parallelogram to the right? So you're looking over here where you see the lines that are kind of darker, and from there you're going to answer this question. Go ahead and flip to page 2 with me, and at the top you're going to see this idea, key concept, area of a parallelogram. This is similar to what's on your formula sheet, and you should have your formula sheet out on your desk for this lesson so that you can reference that and get used to using your formula sheet. So in words, it says the area A of a parallelogram is the product, so we're multiplying, of its base B and its height H. So anytime that you're looking at the base and the height, you need to understand that your base and height have to create that right angle, such as shown in the picture. You cannot use the slanted sides as your actual height because they are forming a slant or they are diagonal. Kind of looking at the next piece where it says the area of a parallelogram is related to the area of a rectangle, as you discovered in the inquiry lab. So the base of a parallelogram can be any one of its sides. The height is the perpendicular distance from the base to the opposite side. So that's where we get that idea of a right angle being formed, is it has to make a perpendicular, or it has to be perpendicular to the base. Take a look at the first example. If you look at the first example, you'll see that this looks very similar to what was on your inquiry lab yesterday, where it's drawn on a grid. When you're looking at your grid, you can remember to count the lines. So 1, 2, 3, 4, 5, 6. So we know the base is 6, and then we have to count the pink line, the pink dotted line inside to find our height, and they're telling us that the area would be 48 square units, or 48 units squared. If you're not sure what the measurement is, always use that safe bet of units. Now we're going to get into an actual example where it's not drawn on a grid, and you're given three different measurements or three different numbers, and you need to be able to identify and use the correct number in order to help you be successful in finding the actual area of your parallelogram. So if I look here, I see the base is 20. My height is either going to be 13 or 11. I need to remember that it has to create that right angle. So I should know that my area is actually going to be this 11 centimeter piece because it makes that right angle. Then I'm going to multiply 20 times 11, get 220, and it would become 220 centimeters squared because I'm multiplying centimeters by centimeters. Go ahead and take a few minutes and solve letter A, find the area of the parallelogram on the grid, and then B, find the area of the parallelogram drawn with measurements. The next part is going to be more of the application part of this, where we're not going to necessarily practice always just finding the area. but we're going to also look for missing dimensions. So we're going to look for a missing base, we're going to look for a missing height. If you take a look at the paragraph here, it talks about a formula. A formula is an equation that shows a relationship among certain quantities. To find the missing dimensions, use the formula for the area of a parallelogram. Replace the variables with the known measurements, and then solve the equation for the remaining variable. Once again, this should sound very, very familiar because we are using the idea of solving one-step equations. So we know that we're going to be multiplying, so in order to solve and find our missing dimension, we're going to use that idea of division. If you take a look at the example, it's telling us that the area is 45 inches squared and that the base is 9 inches. We're trying to figure out the height. Notice how they're replacing the base or the b with a 9. So they have 9 times h is equal to 45. Once again, this should look very familiar because we did this when we were solving our one-step equations. Okay? So once again, we did that while we were solving our one-step equations. So we should easily be able to get 5 for h. And then if you look over here, we should actually be checking our work to make sure that we have the right answer. So go ahead and look at the got it below, and you're going to try and figure out the missing dimension for each of the parallelograms. The last part that we're going to look at is on the back page, and this is just looking at a real-world example where it says Ramilla is painting a replica of the national flag of Trinidad and Tobago for a research project. Find the area of the black stripe. So if you take a look, it says the black stripe is shaded or shaped like a parallelogram. So use the formula A equals base times height. If we take a look, we see that the base is 6 3/4 inches. And once again, we need to remember that our height has to form that right angle. So we're going to use the number 12. It is okay for you to have a fraction or mixed number as one of your measurements. If you're not sure, you don't remember how to multiply fractions, then get up and get a calculator and multiply it out that way. When you go through and solve, you'll see that it's 81 square inches for the black section. Eventually, we'll get to the point where you could find the area of the entire flag because we'll know how to find the area of triangles as well. Jumping down to the guided practice, go ahead and answer questions 1 through 5. Make sure you're reading the directions for each piece so that you are doing the correct process and finding your correct answer. Remember that you should be using your formula sheet for any of your practice questions that you are doing because that's going to help you be successful in the end.